Alright guys, so we're going to learn how to solve trig equations today. So basically, to solve trig equations, all you're going to do is treat whatever trig you have in your equation as a variable. And then at the end of that, when we're going through and solving for our actual variable inside of that trig, you're going to use your unit circle. Where is the sign equal to square root 2 over 2, something like that. So here's what I would love for you to do. Please go through and fill out the unit circle on the back of that gold sheet that I gave you. I saw a lot of you guys already did, so way to go. If you haven't, please pause me and do that. Also, please put in the tangents around there too. That will save you some time when we have examples like this first one right here. So pause me if you need to. All right, so we're going to solve this guy on the interval from 0 to 2 pi. So first thing we want to do is we want to go ahead and get tangent by itself. So if it's helpful to you to go through and maybe rewrite this problem with some y's, like 2y minus the square root of 3 equals y, and then maybe you solve him. And you apply it back to the original. Or maybe you're totally fine with the tangents and you're cool with subtracting 2 tangent over and dividing by -1. Some problems are easier to do with the trig and some are difficult. So anyways, now that we have tangent by itself, what we're looking to do is where is my tangent equal to the square root of 3? That's what this is saying. To be able to solve for x, so really I'm taking the inverse tangent of both sides. So remember, this might happen at more than one place. Where is my tangent equal to the square root of 3? I want you to look around on that unit circle. You'll find it in 2 spots. That's going to happen at pi over 3 and 4 pi over 3. And yes, I need both answers. I knew my answers had to be in pi. Oopsies, that's a box. Because of my interval. Always look at your interval to make sure that you know if you're in radians or degrees. Rad. Let's take a look at another one. Ooh, this one will be fun. So we have 4 times sine squared theta plus 1 equals 4. So once again, if it makes your heart happy to look at this as 4x squared plus 1 equals 4, and you want to solve that, absolutely feel free. I'm going to go ahead and solve it with the sine though. So I need to get sine by itself. I'm going to subtract 1 on both sides. So 4 times sine squared equals 3. Divide by 4 on both sides. So sine squared of theta equals 3 over 4. Then remember how we take the square root, because we need to take the square root of both sides. When we take the square root of a fraction, we take the square root of the top and the square root of the bottom. So I got sine. The square root of 3, I don't know what the square root of 3 is. I'm going to leave it as the square root of 3. Over the square root of 4 is 2. And now the most important thing that a lot of kiddos forget, and I don't want you to do it, whenever we take the square root, we need a plus or minus out front. So when we're going through and actually solving for theta, and we go through, oopsies, and we take the inverse sine of both sides. Oopsies. I need to know exactly positive or negative square root 3 over 2. So I'm actually going to have 4 different spots where this happens. So if you don't do your plus or minus, you're going to miss out on half of your answers. So go ahead and look at your unit circle. Look and see where your sine or your y value is a square root of 3 over 2. Or negative square root 3 over 2. Alright, that's going to happen at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So all 4 of those are my answers. Alright, so for this next one, I'm going to give you a warning. And I really, really hope that you heed my warning. Be really careful about this. Alright, so first of all, I'm going to have cosine times sine equals sine. Now, I have a lot of kiddos that right now would divide by sine on both sides and then try to figure out where cosine is equal to 1. And yeah, part of us are going to find out, we are going to find out where the cosine is equal to 1, but we're also missing out on part of our answers if we just cancel out that sign. Do not cancel out trigs like that. Don't divide away trigs. That's what I mean. What needs to happen is you need to move that sign on over and then factor out the GCF. So I'm going to subtract sine on both sides. So I have cosine sine minus sine equals 0. And then my greatest common factor here is sine. I'll take him out. And then I have cosine minus 1 equals 0. So then the zero product property says that if two things multiply together and they equal 0, I should set both of those equal to 0. So I have the sine of theta equals 0. Cosine of theta minus 1 equals 0. Alright, so first thing. Right here, I am wondering, where is my sine equal to 0? So go ahead and look at your unit circle and figure out where your sine is going to be equal to 0. Alright, that's going to happen at pi over 2 and 3 pi over 2. Wait, no it's not. No it's not. Sine is equal to 0 at 0, pi, and 2 pi. Over here we'll add 1, so where is my cosine equal to 1? I'm just going to get those same answers, 0 and 2 pi. Alright, cool. Alright, now let's take a look at another one. So, right now we have 3 cotangent squared theta plus 4 equals 7. So, if you'd like to rewrite it in another variable, feel free, but I'm just going to go ahead and start solving. I'll subtract that 4. Divide by 3. take the square root. I hope you were careful about your plus or minus. Now, if you want to go ahead and find the cotangent on the unit circle, you absolutely feel free. But what I tend to do, just to make myself feel a little bit better, is I go ahead and I rewrite this in the trig that I'm used to looking for. So on the unit circle, I'm used to looking for tangent. And the reciprocal of negative and positive 1 is negative and positive 1. So I'm looking for where is my tangent equal to negative or positive 1. So go ahead and take a look at that and tell me where are those 4 places where tangent is equal to positive or negative 1. Alright, that's going to happen at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Alright. Now this next one might throw you off a little bit. This is where I genuinely do rewrite it in a different trig, and it makes me feel better. So I've got sine squared theta. Peanut, hush. I'll feed you soon. So this one can look a little bit confusing because there's a sine squared and there's another sign. There's a thing without a variable on it. But all of a sudden it looks a million times less scary when you just look at it as x squared plus 2x minus 3 equals 0. So if we go down and factor that, two numbers that multiply to negative 3 and add to positive 2, that'll be positive 3 and negative 1. So I have x plus 3, x minus 1. So that means that I can rewrite this as sine of theta plus 3 times sine of theta minus 1 equals 0. So then, we'll set these guys equal to 0. Sine of theta plus 3 equals 0. Sine of theta minus 1 equals 0. So we'll subtract 3. Sine of theta equals negative 3. Alright, well you can take a look at that unit circle for as long as you want, but does my y value ever get down to negative 3 on the unit circle? No. The farthest down my y value ever goes is negative 1. So that's undefined. There's nothing I can do there. So honestly, I just cross it out since it doesn't exist. You can write undefined there if it makes you happy. Over here, I'll add 1. So I want to know where is my sine of theta equal to 1. So go ahead and figure out where is sine equal to 1. That's going to happen at pi over 2. So you have plenty of time to go ahead and get your homework done. And we will look at sum and difference identities when I see y'all on Friday. Have a wonderful day.